for coming here. My name is Inaki Villar. Here is my Twitter account in case that you want to follow me. And the title for this presentation is the Bill Shrugged. Okay, this title is based on the book of the American-Russian writer Ayn Rand called The Atlas Shrugged. And the name suggests, and the reference of this image is related with the Atlas. The Atlas in the Greek mythology was a titan that was holding the celestial sphere. And I'm not going to enter too much in details about the book, but you can see these references in the Rockefeller Center, for example, in New York. But in the book, the scientists, the industrials, the innovators, they were like the Atlas holding the world until in one point they give up. So they give up, they shrug, and leave the world fucked up, in other words. So if you allow me, I'm going to change some parts here, and I'm going to change the celestial sphere, the world, by Android Studio, and the Atlas by Gradle. So, and we are not going to give up, we are not going to shrug, we are going to struggle, of course. And build systems are quite important nowadays, nowadays always. So they play a critical role in terms of productivity, in terms of performance, in terms of speed. And sometimes in something that we cannot measure, like the motivation and the happiness. If you're an Android developer, I'm sure that you have complained about the build system, about Android, right? About Gradle. And it's quite important to understand how it works, because sooner or later you're going to face some problems with the build system. It's true that your company can have some dedicated teams to work with the build process, but still, you have to know how it works. Build systems are present in software since ever. As we can see in the last presentation, we saw something with binaries. They were using build systems too. In C, we have CMake, and build systems are present for everything. For dynamic languages, for compiler to static languages too. If you are using dynamic dependencies, if you are using static dependencies too. But we can say that a build system can manage any activity that can transform any form of data, the input, in another form of data, the output. So in our context as Android developers, this transformation could be, for example, coming from a Kotlin file, the source file, to a compiled code, to a class file. The same page for the class file, to a Dalvik executable file required by our APKs. Let's take another example. Independent of the language, this is how it works, usually a static typed language. First, we have our source files that can be like from a local machine, it can come from the controllers in system. Then we are going to apply some transformation from this source to the compiled class, as we saw before. Later, we are going to get these object representations of the runtime environment that we are working, and we are going to generate an executable program. And finally, together with the data and image resources, we are going to get to generate a release package. Build systems are the composition of everything, because at the end of the day, using the Kotlin compiler or the Java compiler, it's only a build tool. It's not a build system, okay? So the build system is the composition of the sum of all the elements that we have actually in the process. Let's see something more specific. This is, not only Gradle. I think that other build systems are using the same approach. When you have different build tools, you want to represent how they are connected. They are using, if you remember the graph theory, the directed acyclic graph. So there are graphs that they have only one direction and they don't contain cycles. That's how, for example, in that case, the assemble task for a Kotlin project knows that it has to follow some steps. Let's go to see the steps. The thing that we want to do is an assemble. Okay, the first thing is going to compile the Kotlin source file. So as we saw before, this is going to imply a transformation from the input, that's the source file, in the compiled code. Next, because the Kotlin plugin requires, we are going to use the compile Java because we have or we need interoperability with the Java plugin too. Next step is going to generate the classes. So the input is going to be the compile code from Java and Kotlin, and it's going to generate the classes. And finally, we are going to package in a format, in a jar format. So far, so good. Quite simple, right? This is how works a simple Kotlin module in a perfect world. But the reality is another. So this is the, if you know the Android Plate project from Google, it has 8 modules, but contains more than 400 tasks and 1,000 relations between the different tasks. And that's our reality. This is only with 8 modules. I'm sure that you are working with projects like more than 100 modules. So imagine how complex would be the build system itself. So think again before complain about, because Android in that case is very complex to build. In summary, with the build systems, a good build system should have some features. For example, convenience. The developer shouldn't spend time on the build tool, on the build scripts. It should be focused rather in developing the code. Correctness. The build system always should to compile in the correct order the files and using the correct compiler arguments. There is one feature from the build system that is called incremental compilation. That means that if you are not updating one class, you don't need to recompile again, right? That's something that we require from the build system itself, right? That has some of the properties. Performance, ideally, build system should finish without delay. You know that it's not entirely true. And finally, scalability. A good build system should work on the same way, like with 100 files and hundreds of thousand files. There are hundreds of build systems around, and in terms of Android, I would say that the most used are Gradle, Bazel, Back, and Maven. Yeah, so some people still are using Maven and Ant to build the Android projects. Back comes from Facebook, and you have a port with from Uber called OKBack, and I'm going to stop a bit in Bazel and Gradle. Bazel is the build system coming from Google. It's based on the internal build system called Blaze. That's the play of the names, Bazel and Blaze. And it has, they have been working with Bazel around 12 years. So imagine how many iterations around the build system they have done, and imagine so how scale can be a build system coming from Google. It has different interesting features, like, for example, you can execute remote parallel builds or steps of the build. Now, if you have a multi-CPU, like everybody have now actually, when you have a multi-module application, you can schedule the execution of the task of one module in different CPUs. So imagine that you can do that so in terms of clouding. It supports more than 40 languages, and that's something that I want to remark here, because it's unacceptable today that if we are working with Scala and in the backend Scala, and then one client in Android and another in iOS, we have to switch between build systems. And then we have to orchestrate everything with a script file being a mess. With Bazel, you have one build system for everything. And I don't know if it would be Bazel the winner of this race, right? But this is the model to follow, having only one build system, not 8, not 7 on the same project. And another company that is using Bazel is SpaceX. So one company that is sending rockets to the space and bringing back. So it's something that is quite critical, right? It's not showing like a message in an app. Another thing that caught my attention from Bazel, in the latest Android Q on the release notes in the official Android site, they show the snippet from one implementation detail of the domain-specific language of Gradle with 2 snippets, one for Gradle and another for Bazel, the first time. And in the last Google I/O, there was office hour with 1 hour trying to help developers to migrate or support with Bazel on Android projects. I'm not saying anything. There are people from Google here if you want to ask. But today, the official build system for Android is Gradle. But there's something happening behind, okay? And this is perfect to talk about the next topic, that is Gradle, right? So, or love build system. Gradle, the first thing I have to say that things have changed a lot. I have to congratulate, of course, the Gradle engineer team and the Android build tools, because the situation that we have today is much better than 5, 6, 7 years ago. Now we have projects with 100 modules, we have data binding, we have a lot of things that we want to support, and still we are struggling, it's true. But you have to think that your final user usually is not a developer engineer. For these people, the final user is you, and we are complaining a lot. So the first thing that I want to stop here with Gradle is I have found in some developers they don't understand, or they have some problems to understand how it works or what is the mental model of Gradle inside your Android projects. So I'm going to define like a stack, and you have to be clear about this concept. So when you're working in Android Studio with your project or with your IntelliJ or another IDE, you are using, first of all, Gradle. Okay, this Gradle can be a local instance of the daemon, right, in your machine, or you can use a wrapper, like here, where you are going to define which version you want to use. This is going to give us some access to some parts, like for example, the internal entities from the domain model of the Gradle projects, like project or task. It's going to give us access to the base plugins, like Java, Maven, or Groovy. So if you want to work with Gradle and Java, you don't have to do anything else. You only have to work with Java. You have to only to import the version, and that's it. And Gradle is including a Kotlin DSL version. So this is quite specific. If you are starting working with Kotlin DSL in your build script, that's something that you have to know. So Kotlin DSL is including Kotlin compiler embedded. That means that maybe can differ from the version that you are actually using, right? And we had in the past some problems when you were in the limit of working with Gradle 4 and Gradle 5. Today, it's good because you're working with, I guess that you're working with Gradle 5 and you don't have these problems. On top of that, we have the Android Gradle plugin. That's the plugin that is going to give us access to define the configuration of our project. Okay, that's something that we are working every day. And not only that, we have a series of a lot of different concepts like flavors, build types, data binding. There are concepts coming from the Android Gradle plugin, not from Gradle itself. So one of the problems that you can have if you switch between build systems is that if you don't have, you are not going to have flavors and build types as entities, because it comes from the Android Gradle plugin. And finally, you have the custom builds, scripts, and the plugin. So this is the basic model of the Gradle stack that you're working, right? So you have the Gradle, the Android Gradle plugin, and then the build scripts and the plugins. Okay? So Gradle, it has like one life cycle that we should know, right? So because all our problems are coming from one of the 3 different steps. Could be the initialization, could be the configuration, or the execution. So the initialization phase, you know that is when we are analyzing, or Gradle is analyzing the settings.gradle. The settings.gradle is like, well, it has this output where we are including which modules are going to be used in our project. So Gradle is going to transform all the modules, all the projects that has found in the settings.gradle in an entity-related model from the Gradle structure, that is project. Okay, so if you have 100 modules, if you put 100 modules here, Gradle is going to take in consideration all the modules that they have a build Gradle file. So, but be aware, because imagine that you are trying to test, what's the name, Jetpack benchmark library, and you are not sure. If you remove the module from the settings.gradle, Gradle is not going to consider as build source, and it's going to be clean for you. So once Gradle knows which projects are involved in the build process, we can go to the next step, configuration. Here is the most critical part of the build. So, and actually is where all the problems comes, right? So I have seen that you have like these build Gradle files for every model. So Gradle is going to try to execute and build the task dependency graph of that. So first of all, Gradle is going to apply the different plugins and execute the code that you have included in the build scripts. That's very important to take a look at what do you have in your build scripts, because depending if you are not doing the things properly, you are going to execute code in the configuration time, and that's not something that we want. And then we are going to create this task dependency graph that we saw before in the first slides. So there is something that sometimes developers, they are not stopped, but by convention in a Gradle project, you can define a build source model. So if you create this model and you put a source set, a typical Java source set like this, Gradle is going to include as binary the code included in the build source in your build script. So, and this has a lot of benefits because all the code can be isolated, or you can extract this code and move it there and you can test, because in terms of testing, it would be easier to test the code in one model and not in the build scripts. So this is maybe confusing, but the whole point of the configuration phase from the Gradle perspective is, first of all, we are going to take the binary produced by the build source. Then we are going to go to the main build Gradle class, main build Gradle file, sorry, to get all the class path included. Imagine when you are using a simple Android project and you want to include the Android Gradle plugin, you are putting in the main Gradle file. But what you are doing, including a class path. And this class path, these classes are going to be included in the main build script. And then in the configuration phase, we are going to analyze all the build Gradle files, and everything is going to be the build process. So you can have one problem in this build Gradle file, or you can have a problem in the main Gradle file. But the recommendation, as soon as you can, try to extract the task, plugins, logic of the build part in the build source. And finally, the execution. So the execution, I'm not going to stop here, but as you can understand, it's going to execute the arguments that we have set. Okay, so we are engineers here, we are developers, and this for us is code, right? Even that we can say that it's a build script or whatever, this is code. And as developers, engineers, we want to do that if it's code, if build scripts are code, so code can be tested, right? So how we can test, how is like the testing in the build process? Actually, if you remember this pyramid model, when you have on the base the unit testing, the most amount of tests should be unit test, and you have integration tests, and finally you have to end-to-end. For the Gradle, it's the same, so we can apply the same model. So I'm not going to stop in terms of unit tests, because it's the same. So you have a unit of code, or you have a class, and you are going to test on a unit of code, like with a test runner. So far, so good. It's the same for Gradle. But what about integration? So what about if I want to test something? Integration test is not going to use only it's going to use the collaborators related to your class. So you need some mechanism to trying to test. And mocking is not the answer, because you're going to enter in complex chains of mocks, and it's not convenient. For integration tests, we have the project builder. The project builder belongs to the class, to the package test fixer from Gradle, and allows you to generate it's going to generate a dummy test, a stupid project. That's the most basic option, the most basic entity in the Gradle projects. So in the moment that we are instantiated a new project builder, we can get a stupid object, and then we can do whatever we want. In that case, I'm trying to create an extension, and this extension is going to be included in the same project that I have created. So if you see the complete test, at the end, I'm trying to test something about the extension created on the plugin, and I can do that with the project builder. So if you need to do something with the integration test, try to take a look of the project builder in that case. But what about end-to-end test? What about functional testing in Gradle? So it's okay, we have tested everything, but we want to go far. So it's possible? Yeah, it's possible with this Gradle test kit library. Actually, it comes from Gradle itself. Look at this. This is like a simple JUnit test, and we are going to analyze a little bit. So with this library, we can create an environment of trying to mock our build process. And we saw before that we need a settings.gradle and a build.gradle file. So we are going to create a settings.gradle and a build.gradle. The settings.gradle is not important here because we are going to only to define the name of the project. But in the build.gradle, we are creating a task. And we are printing a hello world in the do last. One thing here, have you seen this do last, right? That means that, remember that phases on Gradle? This code is not going to be executed in the configuration phase. And that's very important. It's going to be executed in the execution phase. Okay? So we are creating this stupid task, and then we are going to write the file. Now we are going to use the Gradle runner. This is a very important class, and it's going to give us an instance of Gradle with an argument, that the argument is the name of the class. Let's stop a little bit in this class. The Gradle runner, again, is going to give us an instance of Gradle. And you can define different properties. For example, the Gradle version. It's possible that you have your Gradle task, and you wanted to test this task with different versions of Gradle. So you can define to use 5.11, and you want to test with 4.10. Of course, if you don't have the Gradle version installed, you have to download, right? But still, the arguments we have seen, then you can define the different versions of the installation and the plugin class path that we are going to talk in a bit. After that, we build the instance, and we will have access to the build's output, to the build's login, and the execution of the task. So if we continue with our test, means that I can test, first of all, the output of the task that I have created, and I can test the task state of the execution of the build. So everything, and this is a real end-to-end test of the build process. So to use this library, we have to only include the Gradle test kit, but this solves the problem when we want to test maybe a build Gradle file, right, like this here. But what happened about plugins? What happened if I want to test a plugin? And here is here is a problem, right? Because when you are running a test with Gradle Runner, you are using an instance of the JVM of Gradle, but your plugin is including another classes in the class path. How you are going to try to fix this? There are two ways. There is a manual injection. So with the manual injection, you're going to get the classes from the class path of the plugin, and you are going to inject through a class loader, but it's not very convenient. Sounds a lot of boilerplate. But with this plugin, Java Gradle plugin, you don't have to do anything, and the automatic injection is going to happen. And you can test without any specific configuration of your build Gradle files. Another benefit of this library is totally agnostic of the test runner. So you can use this library with JUnit 4, JUnit 5, spec, Kotlin test, whatever you want. It's not about the library. So here, for example, I have a test written with Kotlin test and a BDD style, and the same. I'm creating a build Gradle file. In this case, I'm using two plugins, the base Java plugin and additional plugin. And then I'm setting up some configuration. In the Gradle Runner instance, I'm assuming to use a task from the Java-based plugin. And finally, I'm doing the assertion of the output of the execution of the task and the assertion on the output of some files. Again, without any configuration, using the Java Gradle plugin, and that's it. So interesting. I think that as Android developers, we didn't stop a lot in this topic, and it's quite interesting, and we can improve a little bit our reliability in our projects. Okay, and the final part is measure everything, right? So there's some, well, it's true, right? So there's some people say that, hey, I don't know how to reverse an array linked list or whatever, and I look on on Stack Overflow, whatever, that's okay. But in terms of the build system, you cannot try to change your build system in function of the Stack Overflow answers, right? So some people say, no, you have to put here 8 gigs. What? So you have to measure. And when you have some measurements, so you can compare and then apply the change in your build process. So that's quite important to have tools to apply this difference. The first tool is BuildScan. So I think that everybody knows what is BuildScan. If not, so you have to open or you have to include a BuildScan plugin, and it's going to generate a complete report of your build, and it's going to be sent to the Gradle servers. Okay. So if you want to know more details about BuildScan, I can give you a little introduction later. But it's something that we are using a lot in the Android development. But I want to stop in some numbers that they are doing. It can be very helpful for us. So the first, in BuildScan, it's going to do a startup time. So before, we saw that the initialization phase is going to scan the settings.gradle to try to transform the projects into the project entity. So shouldn't be more than 1 second. Something more than 1 second in the startup time is something wrong that you have in your settings.gradle. Maybe you are checking something in the servers, in external servers. So take a look in the startup time. The configuration time, here is where all the problems is the most critical part, and the baseline given by Google and Gradle engineers is ½ second per module. So do the calculation. Actually, it's not scaled very well because we want to modularize everything, right? And maybe we have 500 modules, and it's not going to be positive to have a lot of time. But this is a problem of Gradle and Android. It's not your problem itself, right? But the baseline is ½ second per module. And BuildScan is going to be helpful to help us to understand which other tools we have in terms of, for example, how many tasks, what's the total script compilation, and the project configuration time. So one of the recommendations actually from last Google I/O is using lazy tasks. So the custom task that you are writing for your plugins or for your build script can be lazy. And if it's lazy, you're going to see very good numbers. Here is 100 modules. Without lazy task, you are going to create during configuration 18,000 tasks. But with lazy, you are going to create only 700. It's going to give us better performance and better numbers in terms of the numbers. Finally, another number that should be interesting is like the garbage collector time. So the baseline, or well, the recommendation is the garbage collector time shouldn't be more than 1 or 2% of the total build. So if you have a build of 10 minutes and the garbage collector time is 40%, you have something wrong, and you have to increase maybe the heap memory or allocate more memory in your heap space, okay? Because well, the garbage collector is going to freeze everything, and it's going to be bad. Okay, so this BuildScan works quite good. So for you, you can do the test. You don't have to do anything, only include the plugin. But in my opinion, the real killer product here is the Gradle Enterprise. The Gradle Enterprise is the same, but you can aggregate and compare the results in of your builds with your team. So if you are 1 developer, 2 developers, maybe it's not important, but in terms of teams with 20 or 30 developers, that's something that you want to aggregate and investigate. With Gradle Scans, you can do that. This is from last week. One guy was saying that, yeah, so they spend like 18 days building and avoid 131 days worth of work. So that's very funny, right? You can do these calculations or whatever, and you can see how many time is saving Gradle for you. So it's not, I was surprised because I was thinking that it was very expensive, but I was told that it's not so expensive. And if you're working in a big team, try to talk with your CTO or with your manager and try to apply for BuildScan. So enterprise, because at the end of the day, if you're alone, so with a BuildScan report, you're not going to do anything. So we have another options. This is a little bit, not spam, but well, I developed this library that is going to instrument the execution time of your build process. and not like Gradle Enterprise or Gradle that is going to send the information to the servers. So you can define where you want to send the data. There are different publishers. You can send data to time series databases, for example, to InfluxDB, to Prometheus, or you can create your own publisher and plug to your part. After that, you can use Grafana to represent the information. You connect that, and it's quite good to work with, again, with more than 5-10 people, because you can compare builds by feature, by brand, by team, by everything that you want to add, because you can, of course, add metrics. You can add, define new metrics, for example, whatever. So, but I want to introduce another thing here. And some people with BuildScan, they have some concern, or some companies, because they are sending the information to the servers, right? Or to the Gradle servers. And maybe they have some sensitive information that they don't want to share. So you can use Talayot, of course, the library that I mentioned before. But in Google I/O, they presented another tool called Tracer. And you can enable this tracer like this, right? In your build or in your Gradle properties, you can enable by Android enable profile JSON. This is going to generate a JSON file in your project, and this JSON file contains a lot of information. First of all, is that you can aggregate this information in your time series database. For example, with Talayot, you can do the same. But you can use the Chrome tracing tool and apply the file. So if you don't know this tool, if you were not working in web, so you have in the Chrome, you just have to type Chrome tracing, and it's going to open a screen like this. You load the JSON file, and you have the information. So there's like some parts. On the left pane, you have the different processes, because if you're working in a multi-threading process, you can see the differences. Then the execution itself, and finally the information related with each execution. I think that this is very interesting, because the build process with BuildScan is giving information about initialization, execution, and configuration. Talayot is only about execution, but with this we can go deeper with the configuration phase, going to apply the performance line by line to where is the problem in our build. So that means that here we can go to the level of now how many times or what's the performance of applying one plugin, like the Android plugin, in all the projects. So you can see here how many times the plugin, the Android or the Android tasks are created for each module. This is from the Plate project. There are 8 Android modules, so we have 8 occurrences. And see how much expensive is creating the Android task dependency graph. Something that we have to pay attention sometimes, and we have to, or Gradle has to work on that. So, of course, you can go by the task itself, and you see that we have different levels. We're going to talk in a bit. But the same, so when you are selecting one task like the transformation, you can be the composition of this task on the different workers, what is the execution time, and the best thing is like you can see additional information. Again, one use case, good use case for this could be to export this information to your aggregated server, time series database, or whatever. So before I mentioned that we have, like, you see that there are different levels. Again, I mentioned before that in a multi-modular project, if you have different CPUs, you can parallelize the builds for different modules. But if you have one module, only you are not going to have like this benefit of parallelizing. So there is a new thing from Gradle 5. They have the worker API that allows you to schedule actions in different threads for the same module and for the same task. That means that this is a situation when I have this task here, the task 7, that is using another thread. With the worker API, you can schedule, you can try to distribute this action in the different CPUs. The Android Gradle plugin is using this feature 95% of the task, and is improving a lot. So, yeah, I think that this is like the build struggle of everything, right? But in terms of recommendations today in 2019, because every year we have the typical Google I/O session about what's new in the build system, how to improve. We have thousands of articles about that. But today, I would say that modularization is a must. The only downside that we have with modularization is the configuration time that we are adding in the build process, right? Remember that we are adding like half second per each module that we are adding. But in terms of architecture, in terms of testing, in terms of abstraction, it's much better. Another thing is keep simple the build scripts. Sometimes we are adding a lot of information like calculate the Git, SHA, for example, calculate the version name. Try to do the simple things. Use Gradle caching everywhere. You have two options, to use the local caching for your machine or using the remote caching, in case for CI is the best case, if you want to use remote caching for different agents in a CI/CD environment. And for local development, if you are using caching, that's very good because the output, or well, a hash is surviving to the Gradle clean. For example, you have the benefit of the incremental compilation, but if you are doing a clean, everything is going to be compiled again. With caching doesn't happen this, because the input for this function happens. Again, try to use lazy and worker API for your custom build scripts, logic, whatever, and use the API implementation to have like the task avoidance task that we are using in Gradle. So, and if you are working a little bit more in terms of build process, build engineering, so this is like the magic formula, trying to improve the things, right? So test, now you know that you can test or apply end-to-end tests or functional tests to your build scripts. Measure, that's important. Take drift your decisions in the build system by measurements, not by Stack Overflow or not by the results in your machine, right? And iterate, right? You find one problem, one bottleneck, continue until it's done. There are multiple resources, so actually there are some videos from YouTube, but actually, so I think that the base at the end is trying to understand how works the build system, and in the moment that you have one problem, you have to know where to address this problem, right? And I think that that's everything that I have for this topic. If you have some questions about, because I don't know if everybody knows build scan, well, I make the assumption that everybody knows, but if you have any specific question about whatever, after these questions, we can talk together. So thank you very much, guys.